Assalamualaikum warahmatullahi wabarakatuh. We are from group section 1, group 1. Our group member is Abdul Azim bin Muhamad Fauzi, Amirul Akmal bin Zuhaili, Muhammad Fathurrahman bin Rustam, and Nazihah binti Zainuddin. There are three properties of insulator that should take in consideration in design insulator, which are type of the insulator material, parameter of the insulator, and type of the insulator used in overhead power line. Mostly, polymer, glass, and porcelain is the common type of material we use as insulator, while the parameter that insulator should have are high mechanical strength, high electrical resistance, high relative permittivity, and high ratio of puncture strength of flashover. Then the typical type of insulator used in overhead power line is pin type insulator, suspension type insulator, strain insulator, and shuttling insulator. The insulator in high voltage is placed between the line conductor and support tower. Therefore, insulator is often exposed to the atmosphere that exposed to various types of environmental stress. Mostly, the performance of the insulator is affected because of the mechanical and electrical stress. The mechanical stress problem may caused by the conductor load due to the low mechanical strength, while the electrical stress in the insulator occur by flashover and puncture due to it has low dielectric strength. Lastly, the effective of the insulation material may give high chance of the insulator to be punctured. So, our objective for this project is to design high voltage overhead line insulator for 275 kV by using glass material. Then, to analyze the performance of the insulator for its environmental issue by using COMSOL software. And lastly, to conduct high voltage tests of the insulator by using high voltage experimental setup and procedure. Then our scope project for this project is glass used as the material for design of high voltage suspension type overhead line insulator. SketchUp software will be used for design the prototype model of the insulator, while the COMSOL software is used for analyze the performance of the insulator with its environmental impact. And lastly, the insulator be tested by using HVAC temporary over voltage dry and wet test. In this project, we have chosen glasses as our insulator material. The proposed design of this project has been generated by using Google SketchUp software in 2 dimensions and also in 3 dimensions. The design of our insulator based on this specification. This is the dimension for a unit of cap and pin insulator, while this is the dimension of the glass insulator.
Hello, hi, Assalamualaikum. My name is Muhammad Fathurrahman bin Rustam. I will explain about the process flow for FEA simulation on the prototype. Okay, so I'm present about the block diagram of general process, the flow chart of the project, and the last one is which is the technical summary methodology of FEA simulation prototype. Okay, so next we go to block diagram first. Okay, this is about the process flow. It start from the forming a group of team member, which is will be studies about the type of insulator and gain idea of information, and then started to design from the idea, and then design the overhead line insulator prototype. And then in designing, so the parameter for the selected insulator will be used to model the 2D insulator design, which is use the COMSOL software. Okay, and then when the design already model in the software, so the simulation and analysis will be due to the insulator. And then when doing the analysis, will be check the troubleshoot of the result, which is either have an error or is successful. So if error, it will be troubleshoot. If success, it will be record the data and record in the report the writing. Okay, so that's about the flowchart. Okay, so the flowchart starting from the information, which is the idea in the theoretical about the high voltage, and then will be set in the 2D asymmetric space dimension in console, this is type for the simulation part. And then in the simulation will be set the electrostatic will be selected to the physics interface. Because it will be to drawing the insulator using the console software, and then in the console will be define the material properties and the machine the design, and then the decision making. Okay, decision making part, which is to check the analysis either have the error or successful. If the error will be go back to the drawing the insulator and also including the defined material properties. And then if the result is already successful, and then we will record the data and the report writing for the observation of the analysis. Okay, the last one is about the technical summary, the methodology of FEA simulation prototype. Okay, this project is aimed to design and analysis the overhead line insulator prototype, and then the overall of the project will be analyze the data result from the simulation, and then the outcome of the performance of the prototype when the stress by environmental impact. Okay, and then the design, the insulator will be modeled by using the console, which is the software that we use to the as analysis, and then they analyze the electrical potential and electrical field intensity since the external circumstance, environmental impact, and then the data will result and collect and that shown in the surface plot of the element potential, electric potential. Okay, so that's all for me. Thank you.
Hello and Assalamualaikum. My name is Amirul Akmal bin Zuhaili and my matrix number is DE190203. In this section, I will present the simulation result for the single disc of the glass insulator by using the console multiphysics software. So the simulation will be divided into two different conditions, which is on the left side is the dry test and on the right side is the wet test. So for dry test, we will use the clean model, and for the wet test, we will be using the contaminated model. Basically, the drawing is in 2D for both of the condition, both of the model, and then for the geometry, we follow all the dimension of the shed and also the creepage distance. And the material used is set according to the proposed design, which is glass, steel, air, water, and concrete. Unfortunately, for the dry test, we doesn't have water because we doesn't add the water layer. But for the wet test, we add water layer along the glass. For single disc of glass insulator, it is subjected to 11 kilovolt, and for the ground, it is set to 0. So moving on to the mesh. So this is the normal element size. So basically, the type of the mesh is depending on the element size, which means that it changes based on the element size. Alright, so for example, this is normal. Alright, so for normal, it will consist 10,262 domain elements and 616 boundary elements. But if I change it to fine element size, and then I build all, and then we can see that it increased to 10,480 domain elements, and the boundary will increase as well, which is to 628. Right, so the concept of the mesh is the same for both of the condition, even at the wet test. Next is the electric potential. Alright, so this is the color legend which used to determine or to indicate the reading for the electric potential. Alright, so here we can see the color around of the insulator. For wet test, we can see that the concentration of the blue is more than the dry test or the clean model. So here at the pin, it is maximum value for the electric potential, and then at the cap, it is minimum value of the electric potential. Same goes with the contaminated model. So the last one is the electric field. So for electric field, we cannot see too much difference. The only thing that we can see is blue, alright, for both of the model. But here at the center of the insulator at the concrete, we can see there are some reading which it indicate in yellow color, and then if we refer to the color legend, we can see that it pointing to 0.8 multiplied by 10 with the power of 6 for the electric field. If we want to see for more specific or more detailed difference, we can see by looking at the graph. Okay, so the shape of the graph for clean model and the contaminated model is the same. However, we can use the zoom box to see for the changes at the graph. Okay, alright, so here for the clean model, we can see that it increased from 0 at some arc length, and it is approximate to 54 mm, right? And then it decreased before the 70, maybe around 68 mm. On the other hand, if we look at the wet test or the contaminated model, we can see that it increased from 0 electric field at some at 53, something like 53, and then it decreased at 70 mm, right? So according to the result, we can observe that for the wet test, it has wider arc length compared to the dry test or the clean model. Alright, so that's all for my part. For the string insulator, I will pass it to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhamad Fauzi, and my metric card number is BE40403. So today I will continue with the design part, which is to design the string type of the glass insulator. So for this design, it needs to perform two tests, which is the dry test and also the wet test. So here are two designs. It's just the same design, but we just add the contamination. So here's the close up design. Here is the dry test, and this is for the wet test. So for this design, it was used to withstand the voltage rating of 275 kilovolt. So after a few calculations, it needs around 15 units of a single glass disc insulator to meet the requirement for 275 kilovolt voltage rating. So after we have done with the design, we can define the material for this insulator, which is it consists of the glass, steel, air, and also concrete. And then for the wet test, we need to add an extra contamination, which is the water and the contamination. So after we have done with the parameters, we need to do the meshing process to find the variable that needed, which is to find the output for the electric potential and also the electric field, and find the comparison between the wet and dry test. So after we build the mesh for both tests, here's the output mesh for the normal one, and then we can go to the study and then compute to get the output result for the electric field and also the electric potential. Okay, after we have done compute, we will get the output result for the electric potential and electric field. So this is the electric potential, and as you can see here, before we go any further, this electric potential, we need to define the conductor and the grounding. So for this insulator, the active conductor was at the bottom of the pin, which is right here, and then the grounding is at the top cap of the insulator right here. So based on this color legend, we can see that the value of 0 kilovolt was at the blue color, while the maximum value was at red color. So as you can see at the electric potential for both conditions, it was hard to find any difference, but as you can see that the voltage of the electric potential around the active conductor was at 275 kilovolt, while at the grounding is at 0 volt. So therefore from here 275 kilovolt, then it decreased to the 0 kilovolt at the grounding. Same goes to the wet test. Next, for the electric field, this is the output of the electric field. As you can see here, same goes for the color legend here, that the blue one is at 0 electric field, while the red one is the maximum electric field. So for the dry test, we can see that the surrounding of the electric field, the surrounding of the insulator has no electric field, while the electric field was focusing only at the glass insulator at the active conductor and the grounding. And then same goes with the wet test, that the surrounding has zero electric field, while it's focusing on the active conductor and also the grounding. Based on this electric field, we can see that the darker color side indicates that there are no electric field or electric stress around the insulator. Therefore, we can see that the electric stress at the active conductor will affect the time span of the conductor, which means that the active conductor right here have a higher electrical stress, which can cause a breakdown at the time span of 5 to 10 years. And then the glass insulator at the second until the 14th glass insulator has less electrical stress, which can increase the time span of the glass insulator. Based on these two electric field, we can barely see any difference, but we can see the difference based on the electric field graph. So here is the graph output of the insulator. We can see that this electric field graph was plotted by starting from the grounding to the conductor. So it starts with the grounding and then conductor right here. Therefore, as you can see that the electrical field at the conductor has the highest electrical field. Based on this graph, we can see that the arc length between 1500 to 2000 has a higher chance of breakdown due to the higher electrical stress. Same goes to the wet test. The difference between the dry test and wet test is the arc length of the insulator. These are due to the contamination that causing the arc length to be increased as the electric field influenced by the surface of the glass insulator. Therefore, it can be concluded that the electrical potential for both wet and dry test can be barely seen any difference, but for the electric field for both wet and dry tests, there are difference in terms of the arc length due to the contamination on the surface of the glass insulator. I think that's all from me. Thank you.
In conclusion, we are able to achieve all our objectives in this project. This project has proposed the suitable parameter and design of high voltage overhead line insulator for 275 kV by using glass material. Then, by using the console software, the performance of the insulator during dry and wet conditions can be analyzed, while the strength of the electrical and mechanical stress of the insulator are also able to analyze. Based on the analysis, the design of the insulator is suitable for the high voltage system. Lastly, this project is able to propose suitable setup of high voltage testing for HVAC temporary overvoltage dry and wet test. The proposed setup was following all the correct procedure and the safety requirement. For high voltage AC temporary overvoltage dry and wet test, for doing this test, we need to use this type of equipment, which is HVAC resonance set, connecting rod, and our test object, which is glass insulator. The function of we use HVAC resonance set is to produce temporary overvoltage, while the connecting rod is to connect the insulator with the resonance set. And this is our test setup for doing HVAC temporary overvoltage for dry test. Our HVAC resonance set and the insulator need to connect with the ground, while the connecting rod is connect between the resonance set and also insulator. Why? For doing wet tests, we need to sprinkle water at this insulator.
Okay, so now I will present about the high voltage AC temporary over voltage testing procedure, which is the left side is about the setup for the dry test and the right side is about the wet test. Okay, that's a spray. Okay, so next is about the dry test first. For the dry test, the insulator clean and dry should be mounted as specified and the prescribed voltage, which is the corrected for ambient condition. So it should be gradually brought out at power frequency and maintained for 1 minute. Okay, and then they should not be punctured or flash over during test. The dry test will be conducted to determine the ultimate mechanical strength of the insulator by increasing the voltage slowly until reach the 33 kilovolt. Okay, that's first about the procedure for the dry test, starting from the clean and dry and mounted with the specific prescribed voltage, and then the flashover that will be observed during the test, and then the voltage will be increased until you reach the 33 kilovolt. Okay, that's for the dry test. And then for the wet test for the HPSC, temporary over voltage. Okay, so the wet test, which is about the test, rain test, which is about the there's a liquid water. Okay, the insulator is with spray with water at an angle of 45 degree in such a manner. So the angle 45 is really important. Its precipitation should not be more than 5.08 millimeter per mil. The voltage is then gradually increased up to the specific voltage, and then the voltage also will be maintained at the specific value for 30 seconds. When the voltage is really will be increased, so the time will be maintained for the 30 second, either 30 seconds or 1 minute, and then the insulator will be observed either puncture or breakdown. Okay, and then the voltage is maintained for 1 minute. This test is also called as 1 minute rain test. As you can see, there's a two type of time, which is 30 seconds or 1 minute. So the wet test will be use the water, and then the water will spray at angle 45 degree, and then the voltage will be increased up to the specific voltage for 30 seconds or 1 minute, and then the observation for the insulator we see about the puncture or breakdown. Okay, that's all from me. Thank you.
And this is the safety procedure that we should need to follow. Firstly, before start doing testing, we need to wear proper personal protective equipment. Then switch off the power and check the earthing before entering the test area. Then sufficient clearance from the surrounding should be provided for the test object. Make sure the equipment in test area is not on before we switch on the power. Then we need to make sure there are no people inside the test area during switch on the power and doing the testing. Lastly, switch off all the supply after complete doing the testing.